Good morning, everybody, and welcome to my channel. Today, I am very grateful to you all for taking the time to be here. This session will be about my teaching and assessment philosophy, and I will take the course of robotics engineering as an example. The robotics engineering is considered as one of the most important topics today, along with the artificial intelligence and system integration to make life better. Because, as you know, any new technologies is developed to make life better. I am Dr. Fawaz Fathi Taha, Assistant Professor in Oman Islamic University. Without further ado, let's get started with the outlines of this course. With the outlines of this session. First of all, we will talk about the general teaching or general teaching philosophy that is applicable to this course and other courses. After that, we will talk about the general information. Then we will look at the references used in this course according to our teaching philosophy. After that, we will discuss our plan and program for this course, the syllabus and the outlines for each module in this course. Then we will move to the objectives and outcomes and what we are expecting at the end of each module and at the end of the course. Then we will consider the assessment philosophy and how to evaluate the students fairly and efficiently. Finally, we will conclude this session with the grading system according to our assessment philosophy. First of all, our teaching philosophy is based on how to develop the outlines and the contents of each course. So we will develop and update these details of the course by comparing the course by comparing this syllabus with the high standard resources such as the syllabus and programs of top ranked universities worldwide, not just for specific countries, because the knowledge, like other resources, is distributed worldwide. Okay, it's like agricultural resources and so on. So we need to find the research outcomes of other top-ranked universities also by comparing the syllabus of our course with the advertised job of the top companies worldwide, and finally with the research outcomes of top ranked of high impact papers. Okay. As for the content, we make sure it is plentiful. Okay. Well, by with about full chapter for every two lectures, and each module in our syllabus is considered as a complete chapter, and we have here 8 modules. It is 8 chapters. It is more than half of the textbooks. To motivate the students and to make the teaching environment more collaborative and interactive and supportive and so on, we have two methodologies. The first methodology is to dedicate the first two lectures with the course description at this lecture and an overview of the course. And this overview, in this overview, we will discuss the challenges, the applications, and the problems. Because in this course, we will learn what are the tools. We will learn the technologies and tools. So we want to be able to choose the right tools, the right technologies to solve the related problems. Okay. And the second methodology is to provide the students with videos, pictures, some simulation programs, and also give the students the chance to share their ideas and stories with us. Because if for example, if the slide contains 100 words, the image may contain thousands of words, and videos will contain millions of words, and the simulation programs may contain more than millions. Okay. So as a general information for this course, we have a prerequisites, we have aims. Aims is the general objectives, and we have also tools. Okay, so the student has to gain some knowledge before starting, or to have some elementary knowledge of linear algebra programming and feedback control, because the robotics is considered as part of control engineering as general, and there is algorithms, and in order to implement these algorithms we need some programming skills, and because we are moving in a 3D space, we have to deal with vectors and matrices and so on. So here our aims will deal with the kinematics, okay, with the movement without considering the causes of this movement, because the causes of this motion is considered as a dynamics. Okay, so we'll talk about the dynamics in general, but a dynamic is considered advanced and postgraduate courses in most universities worldwide, along with the mobile robots, advanced mobile robots, and medical robotics, and artificial intelligence robotics, and actuated robotics, and some advanced topics in programming. So here we will talk about kinematic analysis and design, how to plan trajectories, and how after that how to make control algorithms, how to make control algorithm in order to follow the planned trajectory. And we need some programming tasks. We will use simulation tools like MATLAB in the lab, and as a mini project at the end of this course we will use AROS, and also we'll use a robot studio to demonstrate some concepts. So in brief, yeah, you can see here here we can see here from ABB Robot Studio. This a manipulator, because this type is considered as a fixed base robot. And there is other type which is mobile robot. So in this course mainly is dedicated for these types of manipulator R, because it is considered as a foundation for other types. And this robot has R with joints. Okay. And we can use these robots in the manufacturing environment and in the industries as a teach pendant, has programming language like this programming language, and if we can run this program by hitting this button. So here we can see this robot follow this trajectory. This is a trajectory planning, and here this robot has joints and has end effector. Okay, you can see here the robot follow this program. So just I show you this in order to provide the students a general overview of what we want to learn in this course. Okay. So let's go back to this to the slides. For references, we will use some of the top references worldwide. And here we will have a list of the most important references. Also, we'll use resources from other universities. And many thanks to Professor Osama Khatib in Stanford and Alessandro De Luca in Roma University. Thanks to Victorian Cow in British Columbia in Canada. And so many thanks to Professor Ridwan Al-Qasimi in South Florida universities at South Florida universities and other universities. So here we can see the our modules. Here we have, in addition to the modules, we have 8 modules or 8 chapters. First of all, we'll take overview. Then we will make a strong foundation with the hardware and software components. And then we will discuss the algorithms that we will need to develop in order to control our robot, or to make our robot, to force our robot to follow a specific trajectory planning. Okay, so we will need some analysis, forward kinematics, how to convert these joints values to pose, to position and orientation at the end effector, and vice versa, how to make the reverse process by converting a given pose to related joint angles. And this inverse kinematics is considered as a design problem. Also, we need forward and inverse velocity kinematics and Jacobian, because for any controller we need the information as a reference input. We need the position and velocity, and sometimes we need also the acceleration. So the function of trajectory planning is to provide the controller with the timing profile at each sampling time. So we need to know at each sampling time what is the required reference input to the controller, what is the required position and velocity and acceleration, in order to force the robot arm to follow specific trajectory. And here we can see the details for each module and sub topics for each chapter. Here the objectives and outcomes, and it is similar to what we said before. And now, according to our assessment philosophy, because we provide the students with this a lot of information and chapters, so we are not just our assessment are not just a test of the students' memorization, but rather we test their understanding and applied abilities and capabilities as if they were in a field environment. So we support the students in exams and tests with multiple choice questions and some analysis and design problems with some auxiliary tables and equations. Also, at the end of the course, we expect the students to implement a mini project and this mini project will demonstrate the students' understanding of the concept of this course. So our mini project is considered as a problem, and we want to apply or learn technologies to solve this mini project problem. Our grading is distributed among tutorials, labs, mini projects as 30% to 70% for final exam. Okay, but for remote learning condition, we make this percent as a 50. We make this percentage as 50% to 50%. Here at this point we end our teaching philosophy and course description, and many thanks to you all. If you have any question, don't hesitate to ask. I will be very happy to answer your question. Thank you.